So from our previous demo on the program to compute the area of a circle, recall that we declared there a constant pi, and as mentioned a while ago, constant declaration like the pi is part of the global declaration. So for the header declaration, what we have there in our program is this one: include stdio.h, and then for the constant declaration we have define pi 3.1416. Now this is any constant name, and this part here is any constant value. Say for example we want to define another constant, so we would say number define, say the constant name is tax rate, so that's one word, and then the tax rate is say 30. So maybe in your program you would say how to use that: tax is equal to tax rate divided by 100.0, so to make it 0.30 times say annual salary, where the annual salary is the whole year salary of an employee. And then we get the 30% of that. That is the tax amount that the employee will pay the government. The C library is simply a collection of predefined or built-in functions which are grouped in headers. So a C library is simply a collection of header files. And one of the very commonly used header file is the stdio, right? stdio.h, this one, which contains definitions of the standard input-output built-in functions such as the one we used already, the printf, scanf, okay? And there are so many other functions that we are going to discuss soon. Aside from stdio.h, we also have header files such as math.h. So this contains the mathematical built-in functions such as pow, cosine, sine, tangent, cotangent, square root, and many others. Okay, so if you're going to use those built-in functions for mathematical computations, then you need to include math.h. Okay, so you would say in your program, include math.h. And another one is string. This contains definitions of built-in functions for string manipulation. We're going to discuss that soon. And then the conio.h or conio, that stands for console. The con is console and io is input output. This is standard library, stdlib.h. Okay, there are several functions there, built-in functions that are useful also. Now, each header file contains definitions of predefined or built-in functions belonging to that header file. Now, you can think of header file as shelves. Okay, header files or headers are like shelves in a library. When you get inside a library room, you would have there shelves, and each shelf, okay, so this is shelf number 1, and then another shelf number 2. Say this shelf 1 is for English books, and say this is for mathematics books. Okay, so all the books that are in here are English books, and all the books in here are mathematics books like algebra, trigo, calculus, geometry, and many others. So in the C library, these headers are like shelves, like this one. This is shelf 1, shelf 2, shelf 3. And like in the math.h, all that the math.h header file contain, just like a shelf, it contains all the mathematical built-in functions. Okay, you cannot find in math.h those string manipulation functions. They are found in string.h. The printf is not found in math.h because printf is not mathematical function. That is standard input-output function. Okay, so headers are like shelves used to organize or group together into one header file all the related functions. There are two types of variables. These two types are the global variable and the local variable. The global variable is a variable whose scope is the entire program. So the scope of the global variable is the entire program, while for local variable, the scope is only the function where it is declared. Okay, so let me give you an example of these two types of variables. Say we have here a program. So for our header file, we would say include stdio.h, and then we declare here variable area. So we say float area, and then we say void main open and close curly, and then we have here float type radius, and then our program statements here, the printf, and then the area is equal to say 3.1416 times radius, and then another printf to display the output. Okay, so in this program we have two variables, radius and area. Now radius is a local variable, while area is a global variable. So again, what is this? A single line comment, a single line comment. So that is the single line comment delimiter for single line comment. This is global because it is declared outside of any function. In this program, we only have one function, the main function. And this variable is declared outside among the global declaration, which is found on top of the program. So that's why it's called global variable, because it is declared outside of any function. It is declared on top of the program among the global declarations, not inside a function. And another thing is that for global variable, any function in the program have access to it. So say for example, we have another function like f1, f2, fn, like in our general form that we discussed a while ago. So say we have several functions in the program. All of those functions have access to the global variable. While for local variable, only the function that declares it have access to it. So no other function in the program have access to it except the function that declares it. So the only function that can use or access the local variable is the function that declares it. Like this one, main function has a local variable radius. So only the main function can use this variable radius. If we have other functions here like f1 void f1, and then we have here another, say, integer x. X is a local variable declared inside function f1, and main function cannot use x. It cannot use x because x is owned by f1, and f1 cannot use radius because radius is owned by main function. Only main function can use radius. Only f1 can use the local variable x. But both f1 and main function can use area because area is global. So again, global variables like area, can be accessed or used by all the functions in the program, like main function and F1. So main function and F1 can access or use area. Like in this case, inside the body of the main function, we use area, which is the global variable. And F1 also can use area. You would say area is 31, changing the value of variable, global variable area to 31. That is possible because F1 can access area because area is global variable. But again, this x local variable here can be accessed by F1 only, and this local variable radius here can be accessed by main function only. So the scope of radius is only within the boundary of main function, within this block, this function. And the scope of x here is only this block here for F1. So when F1 is not executed, local variable x is not active or not existing. So again, to summarize, for global and local variable, one difference is that for global variable, scope is the entire program. It exists for the whole program and all functions have access to it, while for local variable, the scope is only the function where it is declared and only the function that declares it can use it. Now, a constant is a programming object or container whose value is fixed, like our pi with the value 3.1416. We declare it this way: define pi. Okay, we have one or more spaces, and then the value. So the syntax to declaring a function is this symbol and then the keyword define and then the constant name, spaces or space, and then the constant value. That is the syntax. An example to that is this one: number define and then the name pi and then the constant value 3.1416. Again, there is no semicolon after that to end. What is identifier? Identifiers are names used to reference variables, constants, function names, label names, and other user-defined objects. Like this one, pi is a constant identifier. Area is a variable identifier. Radius is a variable identifier. F1 is a function name identifier. So identifier is referring to names used for variables, constants, function names, labels, etc. And a valid identifier consists of letters, digits, underscore, and starts with a letter. So is F1 a valid identifier? Yes, it is. It contains letter and digit and it starts with a letter. So when you say 1F, is this a valid identifier? It is not. Why? Because it starts with a digit. A valid identifier has to start with a letter. Okay, so this is not a valid identifier. This one is a valid identifier. X is a valid variable identifier. Y is a valid variable identifier. And area is a valid variable identifier. It starts with a letter and it consists of letters. And then you could say also, tax rate, is this a valid constant identifier? Yes, it is. It consists of letters and it starts with a letter. What is a data type? It's a type or category of data. Each variable can hold only one type of data. So what are the 5 atomic data types in C programming language? First is the character. Second is the integer. Third is the float, okay, which I have already used here as an example. And the fourth is double, the one we used for the program to compute the area of a circle in our DevC demo. The last is void. So this is a data type, void. and it is valueless. The one with the smallest allocation, 8 bits memory RAM allocation, is character. The next is integer with 16 bits RAM memory allocation, and float is a real number with 32 bits RAM allocation, and double type is 64 bits. So the smallest, the next, and then the largest. These two, float and double, are real numbers, meaning numbers with decimal places. But this double is a real number with 64 bits of RAM space, while float is a real number with 32 bits RAM space only allocation. Now, integer is whole number with 16 bits memory allocation. Character is any symbol enclosed in single quotes. Okay, so that's the definition of character. So this is a character constant, a character value, a character value. You might be asking, why is this a character when it has two symbols, the backslash and zero? We call this the null character. Although there are two symbols, backslash and zero, it is considered a character, a null character, which marks the end of a string, which we're going to discuss soon. Okay, so again, remember, a character is a single symbol enclosed in single quotes, like this one. This is a character. This is a character. This is a character. And that is a character. So any single symbol enclosed in single quotes, that's a character value. A string is a sequence of characters enclosed in double quotes. String is 0 or more characters or symbols enclosed in double quotes, like this one. How many symbols are there or characters? 1, 2, 3, 4, 5 enclosed in double quotes. Okay, so this is a string and this is an empty string. No symbol inside. This is not an empty string, okay, because there is a symbol, one space, okay, so that is not empty. This is the empty string with no symbol inside the double quotes, while this one is not empty because it has one space. So anything 0 or more symbols enclosed in double quotes, we call that a string. Now, what is the difference between this and this? This is a character, right? And this one is a string. So again, characters are those one symbol enclosed by single quotes. This is a character, while strings are this empty or with one space, or this or that. Okay, that is one string, and it has 1, 2, 3, 4, 5 symbols and a space, right? Are these three the same? The answer is no. Why no? Because this is integer 1, this is character 1, and this is string 1. How about this? Is this equal to that? Is it equal to this? The answer again is no, because A is a variable. This is character A, character value A. This is string value A. Now again, remember, for these four types, character, integer, float, and double, the conversion specification for character, it is %C. For integer, it is %D or %I. This is commonly used. This one is not commonly used. And for float, it is %F. And for double, it is %F. LF. Take note, LF means long float, okay, because double is a long float. These two are real numbers. This is whole number and this is a symbol, digit or letter or any special symbol. So %C for character, %D or %I for integer, %F for float, and %LF for double. When are we going to use this? Now remember, when you're going to display the value of a variable, you would say printf x is equal to %D. And then what you want to display in here is the value of x, right? And you use %D if you declare x as an integer. If you declare x as an integer variable on top, before this one, on the variable declaration. If x is declared as float, then we would use here %F. If x is double type, we would use here %LF. Say if x is type character, you would use %C. And this is also used in scanf, right? You could say scanf input the value of x, %x, and store it in the memory address of x. What are you going to use here? It would be %. If x is type character, you would say %C, right? Because x is declared as a character, and so you use %C. That's the conversion specification for character type, %C.